Kia ora, Year 13. This is the second part of question 1 of last year's probability concepts exam. So this has got parts D and E from question 1. I found the wording in this question pretty annoying. There were just a lot of words. So let's read through it. It's about the same South Island High School, but this time it's about their senior students. So the school is supporting their senior students to encourage them to pursue their preferred career pathway after high school. In total, there are 475 students in the senior school, and they did a survey at the start of the year with every senior student and their parents asked to identify the preferred pathway after high school. And they found that 71.6% of students were intending on going to university, 63.4% of the total students were intending on going to university and were following their preferred career pathway. So that's your second variable, right? And 25.3% were not intending on going to uni, but were intending on following their preferred career pathway, for example, starting an apprenticeship. Okay, so the first question is to calculate the number of senior students, not the probability, but the number, who were not intending on going to uni and were not intending on following their preferred career pathway immediately after high school. And then there's a claim that looks like a relative risk one. It's claimed that it is twice as likely for students to be following their preferred career pathway if they intended on going to uni compared to not going to university. Comment on whether this data supports the claim. Remember, we have to do that at the end and use calculations and statistical reasoning to support your answer. So this is a relative risk question, right? And then the last one is screaming out to me Venn diagram before I read any further, right? I've got this format of all these bullet points and it's about students and which level 3 stats externals they take. Okay, so that's going to be a Venn diagram one. Right, let's go back to part D now and clean up this big mess that I've made. Right, so we could do this in a few different ways, but when I look at this, I don't see a lot of conditional probability, so I see 71.6% of students intend on going to uni, and I've only got 2 variables. So I'm going to try and do this one with a table again. So this is uni and not uni, and this is preferred and not preferred, meaning that's shorthand for preferred career pathway. So we know from reading here 71.6% were intending to go to uni, and 63.4% of the total students were intending on going to uni and were following their preferred career pathway. It's really important here that it's not 63.4% of those ones. It's not a conditional probability. It's out of all of them, right? So out of all of them, we've got 71.6% going to uni and 63.4% who are both going to uni and this is their preferred career pathway. So that makes this quite easy to fill out. So here's uni here. We've got 0.716 here. We know that this is a probability table, so it has to add up to 1. And here we're going to have 0.634. And that means that, let's look at the other number we've given. Okay, 25.3% of students were not intending on going to uni, but were intending on following their preferred career pathway. So that means that it's preferred career pathway and not uni has got 0.253. And because we've only got 2 variables, that means that we can fill in all of the other stuff in this table. So just adding those up gives me 0.887. And that means that this number must be 0.123. This number here must be 0.284. I haven't done the other numbers yet. I want to read the question and see what I need to do. Okay. Calculate the number of senior students who were not intending on going to university and were not intending on following their preferred career pathway. So that means that I need to figure out this number here, and that's going to be pretty easy, right? So the probability of uni, not uni, and I could write it as a horseshoe, and not preferred is just going to be this number, take away this number. So oopsie, something weird's happened to my stylus. Okay, it's working again. So 0.284 minus 0.253 says that the percentage in that category is 3.1%, right? So that's a percentage, but we don't want a percentage. We want the number of senior students. So it's going to be 0.031 times 400 think it's 475 senior students. That gives me 14.725, which rounds up to 15 students in this category. Okay, so there we go. That's that question done. Right, now this next one is, I think that was a merit question, that first one. This one is a relative risk claim. So there's a claim that it is twice as likely for students to be following their preferred career pathway if they intend on going to uni compared to not going to university. So this is one conditional probability, and this is the next one, right? And we have to comment on whether the data supports the claim. Right, so we've got our table in front of us still. So the probability of it being the preferred career pathway, given that someone's going to uni, means that I'm going to want to have, let's see, what numbers have we got? I've got 0.716 here, and I've got 0.634 here. So I'm just choosing out of the ones going to uni, 0.716. And then in the numerator, I've got 0.634. Remember that when I do a conditional probability, what I'm doing is the numerator number is the probability of both things happening, A and B, and the denominator is just the probability of B happening. So that's what I'm calculating here. Now, that probability works out to be 0.885. Now we do it again. I'll just get rid of this from the last video. But this time we're doing, what's the probability, given that someone's not going to uni, that they are following their preferred career pathway? So the numbers we're going to use here, it's going to be 0.284 for the denominator, right, the probability that someone's not going to uni. And here it's going to be 0.253, right? So the top number is the probability of both of these things. The bottom number is the probability of not going to uni. Now, when you calculate that, we get almost exactly the same number. Right, so if we have a look, chuck that in your calculator and you'll get 0.891. Right, so it depends. We definitely can't support the claim. That's the most important thing to say. Right, so if you're thinking about this like I did earlier, then to three significant figures there's a tiny bit of difference, right? But the school is making a much bigger claim than just the proportions are different. I would say that the proportions or the probabilities are the same to two significant figures. So the claim can't be supported. Remember, what the school was claiming was that this one is twice as high as this one. Just let me get rid of this and get some more space. So I'm actually going to write some words out here so that you can see what words you should be writing out. The first probability that students are doing their preferred pathway given uni is nowhere near twice as high as the second. If anything, it is a tiny bit lower. So really important that we say whether we can support the claim or not. Okay, as I said, I think that was a really wordy question and yeah, just made it a bit painful to write up. Now this next one is about students taking level 3 stats. Okay, so we're going to do a Venn diagram, but first we're going to read it through. What we're asked to find in the end is, given that a student was entered for 91586, which is distributions, but you don't need to know that, calculate the number of students in 2022 that were also entered for 91584. So this is going to be an estimate, right, because this data has been gathered over many years. So assuming that we're not asked about the assumptions, but we've got to assume there were no changes in patterns in 2022, which is probably a reasonable assumption to make to start off with. Right, so let's do a Venn diagram. Look at those beautiful ellipses. Okay, so we'll make this one. It doesn't matter which way we go, but I did it with 91584 here, 91585 here, and 91586 here. So let's just enter the data. 12% are entered in all three. I'm going to do these as just numbers. I might just say that numbers are percentages. 12% there, 9% are entered only for 91584, 14% only for 91584, 10% here. It's a very easy Venn diagram. It's kind of a weird question, right? 57% of students are entered for 585 and 586. So that means that that includes those 12 who are entered for all three, right? So here we've got to have 45 in here. And then for 17% are entered for these two, we've got 12% already here, so we need a 5 here, and exactly the same thing here. Given that a student was entered for 91586, calculate the number of students in 2022, so the number, not the percentage, that were also entered for 91584. Right, so 91586, we're working this out. Probability, given that they were entered for 91586, I'll go through this really slowly. So it's 91584 and 91586 divided by 91586. That's just the usual conditional probability definition. So the numerator's got 5 plus 45 plus 10 plus 12. So the 91586 circle is this one here. And then the numerator is just those who were doing 91584. So it's the 5 plus the 12. 5 plus 12 here. That gives me 17 out of 72, which is 0.2361. But remember, we're looking for the number of students, so it's going to be 0.2361 times 9,985, 2,358 students to the nearest whole number. Okay, so there you go. That's question 1 done. Let me know if you've got any questions. I will work my way through the rest of the paper over the next couple of days. Thanks.